All right, you've made it to video 4. We're picking up on question 19. If you're not on question 19 in your guided notes, go back and watch video 3. You're going slightly out of order here, okay? But this will be the final video, except for an animation. I did not make the animation, but there is an animation I'm going to post that explains all this with prettier pictures, okay? All right, guys, you know I abbreviate all of these processes. Replication with DNA to DNA, transcription with DNA to RNA, translation is RNA being used to make protein. Okay? Now, to do that, we're going to go to part of the cell that makes proteins, which you know this. You learned it way back along a time. We've reviewed it a couple of times since then. All right, it's the ribosome. Ribosomes make proteins. So ribosomes do translation. Well, that makes sense, I hope. All right. So, as a refresher, remember we've got 3 types of RNA. Messenger RNA, which is the RNA we've made. That's the one we've been working with. rRNA, which exists, and that's all I'm going to say about it. And tRNA. tRNA is technically transfer. I prefer translator, because that's what it does. RNA. Your choice which one you call it. It's this guy right here. So each codon has its own tRNA attached to a separate amino acid. Okay, the codon AAA gets this tRNA attached to that amino acid. Each one is specific. Now, the way it knows which codon it belongs to is every tRNA has an anticodon. Now remember, codons are 3-letter words in mRNA. So the mRNA has the codon, UCG. tRNA has the opposite, or the anticodon. U pairs with A, C pairs with G, G pairs with C. So same base pairing rules we know and love, only T is replaced by U, but it's the base pairing rules that match the anticodon to the codon. Anti in the tRNA, codon in the mRNA. Right? Now, we have done this before. We'll probably do it again someday. I've got the steps of translation in your notes. Question 22. We're going to go through them one by one. You're going to match them with each step. The first one's pretty easy to recognize. It involves the start codon. So the first step is to go to the start codon and assemble all the parts. The first tRNA, the ribosome, the mRNA. Okay, all of those assemble on AUG here. Told you it was important. All right, step 2 is you read the next codon. So next codon says CAU. We find a tRNA with the anticodon GUA. That's the anti, remember? And you can see base pairing rules. That anticodon is attached to the amino acid his. And I guarantee if you look up CAU in your genetic code, it'll tell you that HIS, histidine, is the right amino acid. Okay, so we read it and we find the correct tRNA. Step 3, we form a bond. So we add that amino acid. Our protein gets 1 amino acid longer. So this is our protein. It's 2. It should be around 20 when we're done. We're not going to do all of it. Okay? Step 4 is basically the ribosome takes a step. So it's done with AUG. That's the methionine. Been there, done that. So the ribosome goes down just one step so that it can read this next codon. All right? And be ready to add whatever it is. So that's going to be the next process. And notice here it comes in, right? And that's going to add the next amino acid, which is going to be SER. So we're going to go from 2 to 3. That's nice. And we're going to keep doing this over and over and over again. Add on, take a step, add on, take a step, until we hit step 5. Notice our protein's gotten a little bit longer. Step 5 is eventually there will be a stop codon, UAG. When you hit the stop codon, you are done. Everything breaks apart, goes its own way, bye-bye. The protein goes off to do whatever job you've made it for. So you hit the stop codon, you are done. Speaking of, hopefully you are done filling this in. Now, I was talking, so I haven't, but let's see how good I can do. I know start was 1, I know stop was 5. So in between, we read it, we added, there it is, and then we took a step, we shifted down. So I got 5, 1, 2, 4, 3. Hopefully I'm right, or you can argue with me in the comments. I think I'm right. Maybe I'm right. All right, last step. Ooh, I like pictures. It's a good picture. I like this picture. This is an awesome, awesome picture. And if you're not reading between the lines, just saying. Okay, so we have a whole list of things. Ooh, that's going to be a lot of points. Whole list of things that we need to label on this figure. So let's start with the, I don't want to go in order here. Let's start with the location. Translation occurs in the ribosome. So that big blob back there, I don't even know what color that is except for ugly. That big blob is the ribosome. Okay? Now, we've got 2 types of RNA to worry about, mRNA, tRNA. Remember, mRNA is the message, so it's the one that looks like a sentence. The string is the mRNA. tRNAs are more individual. There's 1 tRNA for each codon. So these yellow things here, that's a tRNA. This is a tRNA. You don't have to label them all, but each of these is a tRNA. Okay? tRNA is yellow. Since we're done with RNAs, let's do these 2 codons. Okay? Now, do you remember, and you can go back and look, which RNA has a codon, which RNA has the opposite, the anticodon? We learned about codons first. They're a bit more important because they're down here. The RNA, remember this is our message, this is our sentence. So the RNA is made up of words. That's a codon. UUC over here is also a codon. The opposite is on the tRNA. So UUU, that's an anti. Oh, I don't have much room over here. Codon. And likewise, if I circle over here, AAG is an anti-codon. Okay, so got rid of that one and that one. Oh, only 2 left. All right, amino acid and protein, that's the product. So up here, this pink, salmon, ugly, that's the protein. So the question, guys, you need to be thinking about is which one's bigger? Is amino acids made of protein or are proteins made of amino acids? Protein is the big guy. Proteins, like this one, so that's the protein, are made of amino acids. So each ball is an amino acid. So this ball over here also, that didn't work, an amino acid. So my figure is now ugly. Hopefully yours is a little bit prettier, but we did label everything. All right, I think that takes us to the end of the video. We did everything, which is awesome. By the way, there is a homework attached to this, yeah? How about if you comment on this video saying, I made it to the end, I am a survivor. Let's add 5 points to that homework. Actually, there were 2 videos. Why not? Let's add 10 points to your homework. Add a comment in here at the end, whatever you want to say. And yeah, magical points, why not? So that homework, oh, I forgot about this. We'll do this will be fast. So this will be a good review. This is good test questions too. Because we've done matching on tests before. A is transcription, B is translation. Question here is which one makes RNA? Well, I think RNA is what we did on Friday. Let's see, one of these was DNA to RNA, so transcription makes RNA. That's what we did last week. Today we made protein. So uses tRNA. tRNA is translator RNA, so I think that would definitely be part of translation. Plus, we labeled it in that figure a little while back, so definitely translation. Uses ribosomes. I labeled that in the figure. Ribosomes make proteins. Translation's all about the proteins. So we're doing good. RNA polymerase makes RNA. So let's see, RNA was transcription. Because remember, makes RNA, that was the answer a couple of slides back. Definitely transcription. Makes proteins. I've been saying protein translation. So absolutely, completely. Guys, if you can do that, you can do great on the next test. You can't? Guess what? You can rewind the video. Or you can come to tutorials. So practice that. It's important. Good test questions. And now we're done. This is the homework. It's due tomorrow. By the way, I'll also be checking your guided notes for completion. Should be an easy 100 for a daily grade. I'll be back tomorrow and see you then. Take care. Watch the animation next, okay?